And let me check your homework. Page 17 to 35.
If you're the stuff on the paper, I did like entirely. Oh, I didn't. Wait, is this page? I didn't. Oh. Okay.
Okay, so yeah.
Okay,
Okay, got it.
Okay, yeah, I'll do shows these today and bring to you. That's why I couldn't solve this one. I did tomorrow somewhere.
It was so long. It's not like a whole day. It made me so mad writing it out.
Okay. Got my I did, yeah. Okay. Right there, in your corner. Okay, great.
You'll like it how to do those.
I did both of them. That's how we really don't.
Right there.
I know I got it right. That should be the thing. Yeah. We got a third grader. Shut up, you say what I'm a third grader. You third grader, but you say what it was like 20. And like 15 times goes back. That's what he said. No, actually. It's just even I saw the first one. Because do fractions. Why exactly? That's much better. What year are you then? Oh, you told me. You look psycho, dude. No, you look like a.
It was so.
I think it's not like that.
I should have been left.
Not.
I would have gone great.
Yeah. No, you don't understand. I didn't stash for 3 years and I also treatment so it was like this.
I feel.
You gotta look like it's
It was
like I'll throw it out for a bit. But right now, the problem is I will throw it.
like it's like letting us start.
I know. This needs to. I need a kid right now. No, but that's. No, just so you literally. It's 6 questions. And lots of ask. See what I mean? You said, I think you had like 12 different times.
Yeah, it's like crossing a real word.
And
I think 6.
I did.
they still do two times.
I mean, he's pretty with one hour. See this hobby.
I don't know, it's just.
Okay, make sure.
Yeah.
Well, bro, I don't know why you're judging.
Yeah, exactly. Now
You see the mental work artist when you're not speaking to your mouth. Yeah, but I got it. I know.
Very.
I was bro, I actually woke up.
Oh, let's go. You doing the seminar today with the cats?
I got my gym workout.
Dude, our class would be so much more productive. Like after, I didn't push everything.
I know, but you know what? I tried to practice my flabby.
Are you playing in this special?
I did not know that was in there. Like, gonna buy like a. Someone in the factory.
Someone probably changed. But he thinks I'm gonna experiment so. Cheers. Where's my? You are some my test? No, I don't care about your test. Where's my test go? No, right here. Right now. Let me see. Unlucky.
Oh, look at the physics notebook.
Oh, I know, like, that's not like.
Oh, big physics.
I got it. You always give me
And he
notes.
gives us the notes and then we go through them so slowly. Yeah. No, my class is so easy, it's just so boring.
You try to follow. There's ways of making it interesting.
There's ways of making it interesting.
Bro, my socks broke. Oh, I'm back. Like my feet are so stupid. I'm gonna show them like.
Oh, this is the prison topic.
I was like,
I
was like,
yeah, I did. My good friend Joshua Jones.
I said 2 kids.
That's me, he's too.
I'm not gonna.
I just played it. I used it as a example. Very big difference.
Hey, that's not good.
Like I used what main point two said. I didn't copy like bar for bar.
You stole it, you see that?
Wait, you didn't have the conference in it?
No, it's.
No, I missed that one. Oh.
Okay, let's begin our quiz review. What's going to be covered on the quiz will be limit definition of a derivative, derivative rules. So we've learned power rule, we've learned all 6 trig rules, we've learned product rule, quotient rule, and then natural log and exponential. And so no calculators on the quiz, but you need your answer unsimplified. So number 1 says find the average rate of change of each function over the given interval. It's just no calculus here. This is just rate of change. So just slope, right? So change in y over change in x. Okay, go ahead and try that. I've attached the key so that you can check your answers as you try it, but obviously try the problems first before you look at the answers. Okay, I'll be back in a second. But I will walk through each problem with you. Let's see how much we can do. But
Dude, Donnie and one.
So we're just finding slope to the endpoints. We find W of one, we find W of seven, W of seven minus W of one over seven minus one. Same thing with two, find the order pairs, change in position over the change in time. And then because units are provided for number two, we know it's going to be change in feet per second. Limit definition of a derivative. Now that you know power rule, then use that to double check your answer, right? You know your derivative will just be 4x+3, and the limit definition should match up with what you know to be true about your derivative. Replace every x with x+h from the original expression. And then when you subtract f of x, make sure you protect that with a set of parentheses, otherwise we're going to forget to distribute that negative thorough. Any questions 1 through 3? So if H is the temperature of the oven, then we know 15 represents minutes. So that means 15 minutes into the timer, the temperature of the oven is going to be 420 degrees. But we know that H prime is going to represent the rate of change of the temperature. So the temperature in the oven is cooling by 11 degrees per minute on the 43rd minute. So that negative 11 means that the temperature is decreasing by this amount at the 43rd minute. So we know that the derivative is always some sort of a rate, always sort of a rate of change. Okay. 5, 6, and 7 is asking you for you to find the derivative. Anytime I see a lone coefficient in the denominator, I like to push it out as a fractional value. It just feels a little bit cleaner. That way it doesn't feel like, oh, I got to go through quotient rule just for that number below. So I like to rewrite it, push that 1 over 2x squared, rewrite it as 1/2 x to the negative 2. It feels a lot cleaner here, just the coefficient and power rule. I don't have to worry about. So basically, anytime I can avoid quotient rule and I can instead apply power rule, I'm always going to take that. It just feels, quotient rule works, but it's just cumbersome. And we usually don't want to do quotient rule unless we're kind of forced into it. So if your numerator is just a constant, then we should be able to shift that denominator up and just avoid quotient rule. Number 6, we do want to spend our time to rewrite our function to get each term ready for power rule. Just be careful that pi is just a constant. We don't do 15 pi squared. We don't treat that pi as a variable. That 5 pi cubed is all just a number, and that number will go to a 0. Okay, if you're good with page 1, go to page 2. We have to recognize when there is a need for product rule, when there is a need for quotient rule. That you're working through, let me know if you're something doesn't make sense. Answer the individual questions.
So I don't like these together. So it's square root of t. If they cancel out, instead of square root of t on the other side of this. Yeah, that's fine. Because you that's right. Oh, wait, at 3.3 feet. That's the only 3.3 they had 120 seconds. Yeah, get better. That's the sage. With basically every excellent function that's the sage. So it's plus 3, that's so all that the same for here. And you clean all that up, it should all end up being before x plus 3, which is about It's going to be something. I'll leave this one. Just. Yeah, you have to explain it. Just have to know how to. Oh, oh, it's totally different. Yeah, different moments that derivatives have to with each other. Yeah, so if I plug two in, I gotta have the same for the which are two which are. And then if you plug two in for each of their derivatives, then also have the same slopes, just get a nice smooth transition. That's but I'm pretty consistent. Try working. So here's the idea is that a function is differentiable if the limit like that is this we see. Oh, so it's kind of like a conjugate condition for f prime. Something with basically create f prime. F prime piecewise function. Still be conjugate condition for that piecewise function. Basically, the continuity of that and is cruising. Basically, the continuity as well. There's language rules because it's setting up this in one side every class is longer. Okay, well, so I think it's better. I think it's more. Okay, so you just know, so this was fine, what I needed to use that was. They, like, I needed to practice. Better. Well, if you, so areas back, so I can say that. Earlier. It's whatever I say. Would have been using into it. And then. Stay. This, yeah. Ask for me multiply this too. That's nice. The three in the bottom. This in the bottom. Where it ends up as 3.5 by root 2.
Talking about this piece right here?
Yeah.
Okay, so remember, this is really divided by one, right? So it's really three t to the 1/2. We multiply top with top and bottom with bottom.
Mhm.
And if you can leave your answer like this, but we can clean this up further. We know this is really just square root of t. And you know t is really just square root of t times square root of t. So it can't forget.
I see. Either one work. Would either one work for that? Number 9, where you just showed the cleanup.
Say it again?
Would either one like work if you didn't like clean it up that way?
Yeah, if you didn't clean it up, that's fine.
Yeah.
I just want to show you what the cleaned up version would look like. If you were to clean that up.
Oh, it's just.
So number 8, we have to recognize the equal product rule. Number 9, we need to recognize the equal product rule. Number 10, we can avoid quotient rule because that x can come up easily. We just do power rule. But number 11, there's no way around it. We have to go through quotient rule.
I didn't push through power.
Okay, I'll come back.
I didn't really clean up.
Should be fine.
Yes. Okay.
Let's keep working for another 10 minutes.
Why is it -6x²?
As opposed to what?
I don't know, just how'd you get there?
So the -2 is coefficient, that's not gonna go anywhere. The power rule is for the x cubed. That 3 comes down, becomes 3x². 3 and -2 multiplies to -6.
Oh, I didn't know. Okay,
Yeah.
I'm good.
Now, if that -2 is by itself, then it would go to 0, but because it's attached to the variable, it kind of sticks around.
Okay.
I will go in detail with number 17 and 18 on Monday, so if you're getting stuck on it, just know that I will go through that problem. I'm not gonna go through that today, but the 17 and 18, I'll go through those problems in detail. Continuous. And compared to where the slope is going to be this transition. So the steepness at 2 has to match the steepness at 2 so that it's not sharp. So slope to find a prime. This goes for finding conditions for that prime. Passes all the conditions that the function is continuous at the bottom of it, which is where as the function. Yes, for f prime. Okay, so on Monday, we're gonna continue working on our quiz review. Your homework, just there's that final set of AP practice. I think I wrote it out twice, so it's 1 through 11. We'll cross off that page 221 there. Okay, all right, come get your phones. Yay. What number is it? Yeah, I'll go to that.
Sharing, do you think College Board should make like an AP linear report? Yeah.
I mean, it's surprising that they had an AP pre-calc, but
Yeah.
it's actually a good course. So I don't know if they're gonna add any more of that.
I don't know about AP pre-calc, to be honest, because they did, the optional unit has parametric functions.
Yeah.
And also we literally just reviewed, it felt like we just reviewed the whole year.
Yes,
Like,
yeah,
we didn't really do much else.
that's true. But those review items are so key.
I missed like half of the unit.
And I do understand, actually, 2 years removed from logs and exponentials, and having that algebra 2 topic in there, I think could be beneficial.
I feel like it's good that they like almost universally reformed the way pre-calc was taught,
Yeah.
but it's also kind of like the AP exam's kind of almost a waste.
Like.
Yeah, actually, I apologize. So it's like
I know.
good and bad, you know,
Good and
the AP exam is pretty much a waste, free time and not useful, but the course itself is not bad.
That's right. At least
Like
everybody's on the
standardized.
same page.
Exactly.
And everyone going to AB calculus,
Yeah,
kind of knows that they have what they need to.
Is AP calculation also AP?
Mhm.
Oh, okay.
They're both AP.
I thought so, but I wasn't.
You literally just pay.
Okay, so 14, to find normal line, you have to get the point and the slope. And so the point is easy, just plug -3 in, and then you get the order there, and that's what the line is. Now, to find the slope of a normal line, don't worry about this just yet. Just pretend like you're finding the slope of a tangent line. So you find that price, you plug -3 in, and then you get the slope of this tangent line. But now you have to make an adjustment, because we don't want a slope that looks like this. We want a slope that is perpendicular to it. That's over here. So if I want to transform a slope to the perpendicular slope, I do the opposite reciprocal. So I flip the numerator denominator, and that changes. And that will give me the slope that I was looking for.
Two tangent lines, yeah.
Yeah, it's change the line with the change in the
What's changed? What's changed?
Change is if I have a.
Physics quiz today.
Is it,
The derivative.
I think I get it today.
That's
not what Dude, I'm sure you're fine. You only like messed up the back page.
No, I wasn't actually really certain about anything.
We're gonna do that next Tuesday.
Wait, Evan's funny.
Oh.
Of GMX? Well, would you plug in GMX and then like, man, I want to.
So let's say I have this, right?
I've been getting eight
This-
numbers recently.
You can think of as there's an outside function, that bracket squared.
Oh,
There's the inside portion, which is that 3x squared plus 1.
yeah.
So if I want to find the outside derivative, applying that, so it's just a power rule for that portion. So power rule for that is just a 2 power. There's only leaving right and that. And then multiply by the inside function derivative.
Oh, so then that would be 6x.
You just take turns with each derivative, and then that is changeable. Now, we can get the same thing if we were to FOIL this out and do power rule after expansion. But the benefit of chain rule really comes to play is if something you don't want to expand, and you're able to separate these two functions. And we do that on Tuesday.
Yeah, I like that, like,
structure, where it's like this, we're gonna do it in process, we're not really supposed to like, we're gonna do it in process.
Yesterday was Friday, so, yeah, it's kind of, those.
Should have left like 5 minutes ago.
No, this is one A schedule.
Really? I thought we were.
Monday and Fridays are A scheduled.
They take
Yeah.
advisements to make Friday feel extra.
Mondays and Fridays.
No, that would be really bad for 6th and 7th grade. I get out at after fiscal level, for this bunch of hours.
Oh, that's nice.
Yeah, but me, but it's, I can. If I was a freshman, I would.
Yeah. That's innovative.
Yeah, it's nice having a shortened day because
Yeah. No, especially with 6th and 7th grade, feeling the longest.
that's right. Freshmen have no option to do virtual class. They can do everything.
Really?
I think so. Is that true? I don't know.
I took a virtual class freshman year.
Really? Okay. I took made the assumption that virtual classes were mainly for juniors and seniors, but.
They usually are, because juniors and seniors want to take like stuff like AP macro.
Right.
But, I mean, freshmen, they also, not every freshman knows like exactly how high school works, almost like how units work and stuff. So their schedule usually looks questionable. Mine definitely did. So, like some random class.
I took AP stats in my freshman year. It was pretty great.
Wow, that's really cool.
Yeah, I took, like, what they did is they had like 4 classes a day, but like you could finish a year-long class in 1 semester. So you can take 2
Nice.
year-long classes in 1 year. So I took honors pre-calc, no, honors algebra 2,
Okay.
and then AP stats. So I actually got, so this is my 4th year of math technically.
Wow.
Did you get any stats?
AP stats on the exam. I think I got like a 4.
Not bad.